Welcome the challenges, look for opportunities in every situation to learn and grow in wisdom. With this note, a very delightful morning to everyone present here. This is Anushka Jain, Management Head at Medicaps University, ACM Student Chapter, abbreviated as MUACM, which is a technical community led by students where we organize seminars, events, activities for students to understand technology in a better way. For human civilization to advance, people need to perform research and find spectacular solutions for some core real-world problems. To elevate the passion among undergraduate students toward research and increase the university's research potential, MUACM has brought an initiative titled Research at MUACM. This initiative holds the collaboration of University's Research Cell and MUACM at the base level. So, on behalf of Medicaps University ACM Student Chapter, I would like to welcome you all in the today's session. So, before we begin with the session, I would like to thank Dr. Nitika Vastuhan ma'am and Neha Setha ma'am for their support and constant guidance. Thank you so much ma'am. Talking about today's topic, that is data-driven decision science. We know data is a tool to make decisions, and we can define decision science as a field of study that combines data, data analysis, and their data sources to make decisions. So, now let's learn more about data-driven decision science. And for that, I would like to introduce our speaker for today's session, Mr. Bastin Robins, who is one of India's 20 most influential conversational AI leaders. Along with this, he is the Director of Decision Science at Clever Insight and also a visiting professor at Indian Institute of Management, Nagpur. So, looking forward to learn more from you, sir. The stage is all yours.
Thank you, Anushka, for that brief introduction. And I'm very much happy to be a part of this event. And today I'm just going to take you through a little different way, where few of examples, or I think most people who get inspired to become a data scientist or data analyst, at this modern day, when you go and randomly pick anyone from the market, you ask them what you want to become. The first answer would be, I want to become a data scientist or a data analyst or a data practitioner. So there is a lot of buzzwords. There are a lot of misguidance also is happening in this current scape. So this session is going to really open up a mind for you in such a way that it will make you people a data-driven decision makers. Okay, rather than initially we were very much focused to be more of a thumb rule based decision makers. Now we will use data as a real-time decision making aspect and use data at maximum level to take good and insightful decisions. So let me share my screen. Can you make me a presenter, Anushka?
Sure.
Yeah.
Done, sir.
Okay, thank you. I hope everyone can see my screen, right?
Yes, sir.
Fine.
Yes, I
so great. So where we are running towards, we know that like these days, because of COVID and all this unexpected pandemic, last two and a half years, it's going to be, everything has gradually changed. Gradually changed in the sense the way things happen, the way we thought like, okay, there was a time like you cannot take online classes, especially when you're doing your engineering degrees or medical degrees. But right now there is no other way other than going to it. So what is happening is that entire system got disrupted. Disrupted at the initial first 2-3 months, everyone were totally collapsed in such a way that they don't know what to do and like what is the best practice, how we can take things forward, how can I teach students, how this will work when there are a lot of limitations are there. But what gradually has happened is we start adapting. Last 1.5, 2 years, we start slowly adapting into different environments, sitting from home and taking classes. And especially when you start taking online classes, you could have really seen a lot of advertisements, lot of ads which is coming to you telling that do you want to become a data scientist or do you want to become a data analyst? Like that, a lot of courses started coming, and all you people started attending classes in Coursera, edX, and all this platform to learn what is this and how it is going to gain a great potential. And when you see in the job market right now, the highest and the highest paid job is a data scientist job, and highest in demand is also data science job. You can see a lot of courses coming, everything is coming. But we should know one thing very clearly. When all of a sudden data science started becoming very much a booming topic, when I was starting to work in data science field, it was not at all known to majority of people. When we say we are working in data science, most people don't even know what it is. Years ago. But right now, if you go and ask anyone, they may be any level, they will tell what is AI, what is data science. So that much we have moved it forward. But at the same time, we have a great gap between what we are learning and what we are applying. That's real. Most people think, okay, if I start completing some MSc or BSc or BTech data science courses, I'll become a data scientist. No, absolutely no. You cannot become a data scientist or a data analyst just completing a course. Why? The reason is, how many of them have watched Sherlock Holmes movies? You can raise your hands. How many of them have watched Sherlock Holmes movies? Or how many of them know what is the story of Sherlock Holmes? Yeah, I think most of people have seen. I would say a data analyst or a data scientist job is exactly like a Sherlock Holmes job only. That means you get into a space and you start, normally when you see the movie, whenever how Sherlock Holmes solves the problem, when there is any kind of crime or anything happening, he's first visiting that place and start collecting lot of information about lot of clues, lot of hidden clues, everything. He start collecting it without any assumption, then come back to his home or his workplace and he arranges everything and start connecting one to one. Once you start connecting, then you start building an assumption who can be the potential culprit in this. Same way, a data scientist job is not a software engineering job where you go and learn Python and R. Yes, tomorrow I may become a data scientist. No, absolutely no. There you need some level of fact knowledge and some level of logical and out-of-box thinking to create assumption itself. So rather than, if how many of them have heard about machine learning and deep learning, neural networks? How many of them have tried something and very much inspired to do that? You can see almost most of people are raising the hands. The problem is, what happened is, like, data science is a very big ecosystem, and to take a data-driven decisions, it is always not mandatory that you need to know machine learning or deep learning or NLP, etc. You just need to know how to analyze data from a core. So this session is going to open up that and show you that right path, how to become a great analyst. First you become an analyst, then you become a data scientist. It's a slow and steady process. No one can become a data scientist with 2 or 3 years of experience just like that, unless and until he works damn hard, or the type of problem he's trying to solve is very, very, very large. Okay, so whenever normally as a data practitioner, I normally like to call myself as a data practitioner, and when we are working on different data, some data will make you very much excited, some data will make you very much interesting, some may be very much boring. You won't believe there are data which may be of a serious problem, but when you see the data, you start feeling very much bored. That time we easily get discouraged. The problem is, like, we don't know who is correct, whether our analysis is correct or someone's analysis is correct. So we start building lot of blind intuition. End of the day, we will not know where to point it out. Now, during that time, one common quote which I really like, which always inspires me a lot, is this quote. That is, data will talk to you if you're willing to listen. What does it mean? That has a greater meaning. If you have a data and you directly start jumping and analyzing the data, you will end up in nothing. You can never analyze anything just like that. First and foremost thing, you should know exactly how to talk to your data. So how to talk to your data? I will show you how we are going to do. If you're asking the right questions to the data, your data will start confessing in front of you. If you are not having the right question, the data will become very much a boring topic for you. Within few minutes, you'll get bored. What happens is when you open a spreadsheet of data and you start seeing it in a little bigger spreadsheet, within few minutes you will get bored, because human eyes are not comfortable with seeing numbers, but they are very good in visuals. So it's easy for a person to get bored when you start analyzing a data. So how to solve that? Let's see how it is. When I'm telling about data, it can be any type. You can take a tabular data, textual data, or audio data, video data. All these types of data are there, but all are only known to a computer. A computer knows exactly what is a tabular data, textual data, audio data, video data. End of the day, all this data needs to convert it into binaries. So when it comes to binaries, there is no difference between tabular, textual, audio, and video. So when I'm talking about data, you know that there are different types of data, which is tabular, textual, audio, video. All are just formats of data, not actual data. But as a computer only knows binaries. So all this data becomes very much irrelevant when they are converted into a binary format. So end of the day, you don't need to worry about what type of data you're handling. A computer's ability to understand the data is only by means of binaries. So once the data comes from that very high abstract point to a lower abstraction, then it is easy to understand things. When it comes to lower abstraction, the data becomes pattern driven. There will be some level of pattern in that. If you start analyzing the pattern, you start building interesting insights from that. Now, I'm going to give you a very small challenge. Okay, this challenge is very simple. That is, you will be given 3 questions. Each question's 10 seconds. Okay, so 3 questions, 30 seconds. And I will be changing the screen exactly after 10 seconds each. Fine? Shall we start? I want everyone to participate. You can post your answers on the chat box. So let me keep my chat box open. Give me a second. Fine. So let's start now. How many numbers are above 100? How many numbers are below 10? Okay. Which quadrant has the highest total? Okay. Now, what happened is, like, I can see a lot of answers coming here. Like it is like 4, 4, 5, some 105, like different types of numbers are coming, and most people are not sure about it also. Not to blame anyone, because human eyes has some limitations in faster calculation. Now, I'm going to give the same 3 questions. Okay. Again, I'm going to repeat the same 3 questions, but with little visual clues. Okay. I'm going to give you slight clues. And let's see how many of them are able to understand things faster. How many numbers are above 100? How many numbers are below 10? And which quadrant has the highest total? Great. So what we are trying to see is a very small set of number, which is pretty much, very much small. In that, when I'm giving you the first time question with 30 seconds for each 10, majority of people were guessing numbers. They were trying to go through it, but most of them were correct, most of them were wrong. Now, if I didn't show you this if I didn't repeat the same exercise once again, none of them will be agreeing upon each other. One will be saying, no, there is only 4. Another set will say, no, there is 6. So both of them cannot agree to it. The reason is we are not sure about it. It's not sure. It's something what we found. As soon as possible, we start guessing it. But there can be other aspects also which is present. So human eyes can shortcut the process of decision making when it's seeing anything through a picture or a visual. That's what is more important we should understand when you're handling with data. Now, let's get into some interesting space. How it all started. From 1950s till 1980s, we call artificial intelligence. That means any system which was automated, like if a switch is getting automatically on or off, or if anything, any kind of work which is done automatically, we call them as the early stages of AI system or artificial intelligence systems. Now, after 1980s to 2010, another sub-branch, it's not another branch, it's a sub-branch of AI start coming into the picture. That's where this machine learning was very much known. Those days, we know that ML is not something new. It is there since years, but at this moment, it is the same old wine which is packed in the new bottle. That's nothing but statistics or statistical models which were there before the name machine learning comes. Again, got a new name with a new identity called machine learning. So it's not totally new. It's already there. We initially call them as statistical models. Okay. Now, from 1980s to 2010, we were using a terminology called machine learning, that is ability to classify something or ability to find out a number or predict a number. Now, from 2010, another sub-branch of machine learning was born called deep learning. Okay. So the majority of people, if you ask what is deep learning, they'll be confused with whether machine learning and deep learning are same or both of them are different. So basically deep learning is nothing but it's a subset of machine learning. It's not a totally different from machine learning. It's basically both are the parent branch is AI, the second child is machine learning, and the child of machine learning is deep learning. How many of them use Facebook? How many of them use Facebook? No one? Yeah. I can see a lot of people using Facebook. Now, have you ever seen that when you go and upload a group picture of you people going some outside or some party or anywhere, you take a group picture, and when you come and upload to Facebook, within fraction of second, you can see automatically Facebook suggesting a tag on their face, suggesting this person is this person. How many of them have watched that? You can see most of people. Even in Instagram also, or Instagram or any social media, if you go and upload a picture, within fraction of a second, you can see auto tagging features coming, which is automatically telling this person is this person is this, tag them. That is the power of deep learning. How it is able to understand. Even human eyes won't be that much, sharp to identify whether that person is this or not. We get slightly confused. But deep learning systems very clearly put bounding boxes above them and ask us to tag this person. It will recommend top 10 people whose profiles matching, and who is having the highest priority will be in the first. How many of them have done that? You can see most people have done that. That is understanding any complex data structures like audio, video, or picture images, and predicting or detecting any object or entity is purely a deep learning problem. Now, let's go above. So for all these things, the fundamental thing is you have to learn to love the data. How many of them really feel data is the real hero? How many of them really feel data is the real hero? Yeah. Because if you have good set of data, you will get good insights. If you have a garbage data, it's like garbage in, garbage out. Whichever model you put, it will not work, or it will not give you the correct intuition, or it won't give you anything what you really want to do. It will not give any effective results. So always you should understand, be a data-centric person rather than a tool or tool-oriented person. Like modern days, the problem is everyone go and learn Python, everyone go and learn R, but after learning that, they will be like clueless that what is next. They'll go and search for a lot of tutorials, and they start working on some machine learning models, start doing some basic feature engineering. Once the model is getting it, go and upload into Kaggle. These things are done. How many of them have really opened the data in a spreadsheet and start spending more time on analyzing that data rather than directly opening it in Python? How many of them? Have you people did that? Open up a data set and spend more time on understanding the patterns inside that before using any kind of tools. That's what is more important. That's why I say you have to be data centric. When you become data centric, you will not jump into any tools. First, you will see whether my data is really good. Now, I'll give you a very small example here. This is a company which is having 4 different branches. One is in Boston, one is in Chicago, one is in Detroit, and one is in New York. Now, this is a sales report of 1 year from January to November. You can see all 4 branches are performing and their performance has been there. Now, when I calculate the average of all the branches, I can see average is same. Their average sale is same. The average variance is 10.0, 10.0, 10.0, 10.0. Average, variance sales is 3.75, 3.75, 3.7, 3.5. How many of them, and my question here is, how many of them think that all 4 branches are identical? That means, yeah, all 4 branches are performing similar because they have the same average price, same average sales. How many of them believe this is correct? All 4 are identical. You can see in the chat box, yes or no. Okay, very good. I can see a lot of people giving yes, no. And I can see one person telling no. I don't know why they want to tell no. What may be the reason? Sakshi, why you feel it is no?
Yes, sir. Good morning, sir.
Yeah, why you feel it is no, it's not same?
So their average and variance may be same, but their performance is not identical. Like in different months, different branches have performed differently. Overall, their result was same, but every month they were performing differently.
Very good, very good. I can see lot of yes, but only one no. It's not your problem, because that's where I'm trying to convey what I'm trying to show you. See, I'm the same data. When I'm slightly changing and interpreting using a small visual, this is a reality. Boston market is steadily growing, Chicago exactly dipping after 10, Detroit market is near to the perfect, and New York market is fluctuating. Now, how many of them how many of them agree that all 4 branches are identical? Do you believe that all 4 are identical? No answer? Are 4 branches identical in this way? No, it's not identical. So from a very small set of data like this, if we can make such a big blunder mistake, what if the data size is very much huge? So we need to understand our ability to interpret the data should be very high before building any model or before focusing on deep learning and neural network and everything, because everything runs. Neural network, deep learning, machine learning, everything are like a machine. It's like a grinder machine or a mixer machine, whatever it is you can consider. If you put the right type of food items only, it will grind and give it. If you put some stones and everything, it will not grind. It may grind, it won't be useful for you. So you should know what to put first. So in order to do that, you should have some idea about the data, what you are going to put inside that model or that function. So now the question comes is, what can be the core of analytics? How can I learn analytics in a very systematic way? Or how can I become more of a data-centric or data-driven decision maker? So this question comes for everyone. So most people, as you people have gone through different courses online, studying different online courses, which are more emphasizing on predictive analytics and machine learning than focusing on data science and data analytics. Let's see what is the core fulcrum of that. So for that, I would like to take an example of a healthcare system. Generally, you know that healthcare is an example. So most people will be able to correlate what I'm trying to tell now. So let's see, if you're having a illness, okay, you have an illness, you're going to visit a doctor. When you go and visit a doctor, the first thing what the doctor asks is, okay, what is your problem? What is your symptoms? Since when you are having this problem? Which medicine you were taking? When was the last time you consulted a doctor? What was your last blood sugar level report? Like that, doctors start asking different questions. All the questions are about the past, right? That means what has happened. Maybe the result which have whatever the doctor is trying to see is about last 1 week or last 1 month report. That phase, what doctor is trying to do is she's trying to collect as much as information about your past. So indirectly, a doctor is doing a descriptive analysis. So we call them as descriptive phase. That means analyzing data of past is a descriptive analytics. Now, after doing that, next thing what happens is the doctor will think, okay, fine. This is what has happened. Let's do one thing. Let's check what is your current BP or sugar value. So the doctor will ask in the real time, okay, let's do a couple of, tests to see how is your cholesterol level today, or your sugar level today, how is your, are you really, so in the real time, she's trying to collect information about you. That is about your present. Whatever she collected about the past, the same thing which she is trying to see it today. This phase, the doctor is indirectly doing a diagnostic analysis. We call them as diagnostic phase. So after doing both this analysis, that is descriptive and diagnostic, the next doctor will predict what will happen to you. How it is possible? The doctor will see your past and present and see, okay, last month you were having a you were less diabetic, but I can see significantly today your sugar level has increased like anything. So what happened here is doctor is trying to see the trend, whether the trend is upward or trend is downward, to see whether are you going to become sick or not. How it is possible? Only after conducting the past and present analysis, doctor is able to predict what will happen to you tomorrow. Now, most people thinks that these three things are the core of analytics. No, they are, but not completely. Most people get disconnected from this point, thinking that, okay, if I do prediction, then ultimately the problems are solved. But the reality is not like that. How it's changing, I will tell you. See, a doctor predicting what will happen to you tomorrow will not completely solve your problem. But partially, yes, it's a starting point for solving a problem. When your problem gets solved, when the doctor is able to prescribe your medicine. So after doing this 3 levels of analysis, past, present, and future, the doctor will take the prescription pad and write, okay, take this medicine morning and evening. Okay. So you will get cured. The moment you start following that medical prescription, you get cured. No doctor will write on your prescription pad what is your tomorrow's predicted sugar level or what is your tomorrow's predicted cholesterol level. They will directly write an action. So conversion of all this analysis into an action is called prescriptive analytic. Prescriptive analytics, we call them. So to do any prescription, you have to be a domain expert. That's why I always say, when you start becoming more data science, or you want to become a data scientist or any domain in the area of data science, first and foremost thing, you need to pick a domain. Either it can be healthcare, pharmacy, logistics, BFSI, transportation, or education, government, or public health. All these areas, you have to pick any one domain and be a master in it. Understand the domain better. That's the reason most of the engineers who complete their engineering degree and directly go into data science field have the highest chance of failing in that field. But the person who completed an MBA or maybe from an business domain, when he start adding analytics as a skill set, they tend to succeed very much higher. That's why you can say most of the people who are great scientists are not directly from engineering background, but are the one who has worked in that particular domain better. So if you understand all the three phases, then this is the core of analytics. This applies in every single different domains. It can be telecom or any domain you take it. The concept is same. You need to do the past analysis, present, future, and you convert all these three analysis into an action. Conversion of all the insights into an action is called prescriptive phase. So be a domain-rich person. By picking one domain, you cannot master in every single domain. You have to pick one domain, understand the variables in the domain, understand the terminologies in domain, understand how the facts of the domain better, then start exploring the data, then you become highly successful. Now, the next question which comes is how data can benefit me, or which tool should I use for data science? How many of them have this question? How many of them have this question? Which tool should I use for data science or to make a decisions in data? Okay, the majority of people are asking this question. So when such question comes, my answer is very simple. You may be a little surprised, but the answer is very clear. I always believe one thing, that is tools are important, but technique is everything in data science. You can learn a lot of tools, but technique is going to be the same. So if you spend more time on learning the techniques, you can use even a paper and pen to solve a very complex problem, or even a basic spreadsheet. Far better. You don't need advanced algorithms, advanced deep learning models, heavy computation, high GPU, high GPU machines. All these things are not needed. If you have a computer, if you have a spreadsheet, and if you have some common sense, you can really solve the problem. This is the reality which I always say. So a person who knows spreadsheets 100% can be called as a good data analyst. This is my take on it. Now, let me take you to one very interesting thing. So what has happened is, I'm going to give you one very good example here, and then you'll know what is the importance of understanding data and domain better. How many of them heard about Titanic incident? How many of them have watched a movie called Titanic? Okay, I think most of people could have. It's one of the most romantic, tragedy-driven movie. And I think when you watch the movie, you will get a lot of ideas. So you will be able to correlate a lot of things here. Now, this is a very small data set. You can see that there is a column called ID, there is a column called name, age, gender, and survival. When the Titanic ship got hit in the iceberg and it started sinking into the water, a lot of people died. A lot of people survived as well. Now, what happened is when the ship got sinking inside the water, the rescue team came. They came with the logbook, which was having the ticket details of every single passenger. For example, if 350 passengers have traveled, all 350 passengers detail was there in like this, like name, age, gender, survival, and another column was added that's called survival. So whenever they found someone's body, someone who has died, their bodies have been found, they put it as non-survived. And whenever they found someone alive, they kept it like, okay, they have survived. Now, what has happened is, just give me a second.
Yes, sir.
Okay. So, you know that this was a small example record where like every passenger and their survival status was saved. So you can see there are a lot of places when they found someone's body, then they said no, not survived. When they found someone alive, they put yes. But you know that during that time, a lot of people went missing. A lot of people went missing. In that time, it's pretty hard to tell that whether they are survived or they are alive. We don't know. So these columns, these rows were kept empty. So as machine learning and statistical models started to come very much alive into the modern day usage, people start building a model to predict whether that particular person is alive or not. So what has happened is that model was able to give 70% accurate. That means the model was able to predict that, okay, predict these variables to see whether they are survived or not survived. Now, we know that 70% accuracy cannot be considered to be as great. Same time, it cannot be just ignored as well. Now, in machine learning or deep learning or anywhere, to increase your accuracy, there are two different options. One is you should have more number of rows or you should have more number of columns. In simple ways, in this condition, we cannot have more number of rows. That means if 350 passengers have traveled in Titanic, I cannot take some other ship's passenger list and attach here. That won't work. So I can strike out that I can strike out that option where number of rows I cannot get it, because if 350 passengers have traveled, only the 350 I can use. Can I add more number of columns? Slightly, that's possible. Can I create new column from existing column? That's possible. So what happened here is we start creating new columns like ID, name, everything is same, but you can see there is a new column called kids created. Now you may be asking, like, how is it possible? Because we don't have information about that. So what happened is, with the basic logic, if the gender is female and age is between 18 to 25, chances of having kid is 1. If gender is female and age is between 25 to 35, chances of having kid is 2. If gender is female and age is between 35 to 45 plus, chances of having kid is 3. It's not exactly the accurate numbers, it's buckets. We call them as bins, the chances, approximation chances. Once this new field has been added, what has happened is the model went from 70 to 90% accurate. Can anyone tell me what may be the reason? Can anyone tell me what may be the reason?
So we segregated the data accordingly, and that's why the accuracy increased.
Not completely, but yeah, it's a good try. Any other reason? Let me see how many of them really watched Titanic movie.
So by doing this, we increased our sample size.
No, just don't go with that statistical point of sampling techniques. Just think about what has happened in that incident. What may be the reason our accuracy went high just by adding number of kids column.
So because kids and women were saved before men.
Who was that?
Aditi.
Aditi, we have to give a clap. Yes, absolutely. See, when you see the movie very carefully, you can see Titanic is 3 level layered. Okay, the base, second and third. High class tickets were in the third, and second class tickets were in the middle, and the base class tickets were in the base. So when the ship got hit in the iceberg, water starts accumulating in the basement first. Slow and steadily within hours, it starts filling into the second floor, third floor. That's how it was. So we know that in the basement, whoever were there, chances of survival was slightly less. In second layer, yes, chances of survival is slightly okay. And someone who is in the top layer, chances of survival is even better. But what has happened is, like, when the water start filling in the basement, people have start moving to the second floor. And again from there to the first floor. The more and more people start going up, what happened is all the lifeboats were kept in the top. Now there are kids, women's and everyone. So what has happened is they decided, okay, men's, we can manage it. So let's give the lifeboats for the women who were carrying kids. Now, what has happened is every woman who were carrying a kid was given the lifeboat as a first priority. Now, we can come to a point or conclusion that any woman who was carrying a kid, chances of survival is 99%. So that means females with kids could have survived. Now, what made us, now the question is, okay, just adding kids column will make our model highly accurate? No, it can be, maybe. But when we know how the decisions were taken during that incident, we were able to build one feature called kids, which helped us to really make a decision much, much clearer. This is the power of domain knowledge. When you start building a model, if you understand what is that particular problem you're trying to solve, what has happened, gather as much as information, then your ability to take decisions will be very much narrowed. Okay, so Now what happened here is you can see we have given lot of columns. We are trying to predict a column called survival. Okay. The column name is survival. Using the name, ID, age and gender, can I predict the column called survival? Whenever we end up in a situation where we are trying to predict one column type, we call them as supervised learning. That means from the given data, the data should have a header, column header, and I'm trying to predict any one column header type. That's that type of problems we call them as supervised learning. Now I am taking the same data set and I'm removing the column, the header column. You can see now we have data, but we are not sure what each column may represents. Okay, the first one I can consider as an ID, second one as it's a name, but other things, MF and all these things, it can be anything. I cannot blindly say that it's male and female, right? So now in computer science or in AI or machine learning area, when such kind of data comes, we need to understand, is there any commonality, any kind of relationship between each passenger, or are they any relationship bonding between them? So when such kind of problem comes where we don't have a header, we don't know what to predict, such kind of challenge, what we do is we apply any algorithm into it, and the algorithm starts splitting the passengers into different clusters, like cluster 1, cluster 2, cluster 3. Each cluster may be having some relationship. For example, cluster 2 can be the youth, cluster 3 can be the older generation, cluster 1 can be the one which has some common relationship. Such kind of problem we call them as supervised learning. Okay. Now, why we need these things? Whenever we are doing data analysis, sometimes your data may be incomplete. So that time you may be needing these kinds of algorithms to identify and fill the data where it is empty. So keep it in mind when you have to predict something which is not there, is some missing values there you want to predict, you can use supervised or unsupervised techniques. Now, what and how and where I can apply this? So let's stop with all these general theories and let's get into some practicality. Okay. That is, I'm going to give you 3 different examples. We'll typically see what a data science or a data-driven decision maker's day-to-day job will look like. So I'm taking an example of Richard. Okay, Richard, he is the CEO of SimplyBuy. In order to build a reliable business, he has few requirements to the data science team to make better decisions. Consider this is totally factual and more for a stimulation purpose. I've just created it. Consider there is a company called SimplyBuy, which is allies. You can even consider as Amazon. Okay, so every day the CEO of SimplyBuy has hired a very strong data science team, and every day he's having different questions, different business questions to ask to the data science team, whereas they come up with the results. So typically, let's see one day what happens. So he's asking, can I know which product can sell together? That means, can I recommend products which can sell together in our platform? Next is, can anyone help our HR team to shortlist resume faster and save time? That's also a problem because a company like Amazon will receive even thousands of resumes per day. So my HR team may be very small. I cannot go each and every resume, but I have to be very transparent in my hiring process. Then what are customer feedbacks about our products across geographies? This is 3 questions. Now, these 3 questions, the data science team will take it. They 3 are business problems and they convert them into data problem. That is from where data comes. For example, for the first one, can I know which product can sell together? Data can be retrieved from SimplyBuy inventory. Can anyone help our HR team to shortlist resume faster? Yes, candidate application can be retrieved from job portals. And what are the customer feedbacks about a product? So we know that we can gather data from social media using their hashtags and start analyzing it. Now, take the first one. Okay. First one is similar product recommendation. So what we'll do is we'll take a data like this. This is a user with an ID 1, user ID 2, user ID 3 like that. And what item they have purchased. User 1 purchased apple, user 2 purchased orange, user 3 purchased apple, user 4 purchased grapes, 5 milk, 6 apple, 6 grapes. So we have the frequency of their shopping. Now convert them into, transpose it into a structure like that. Keep all the items as one column and keep all the user as one row. Like this. Rather than putting 1, 2, 3, I've just put a direct name for them. Now we can see James bought apple. So James 1 for apple. James didn't buy orange. So 0. Then give me a second. Let me keep this somewhere. Then James, Rick, like that. We start filling 1 zeros for all. Now this will not solve the problem. When you apply a little conditional formatting and apply color only for the value greater than 0, you can see some interesting pattern. So can anyone tell who has similar purchasing history like Gracie? Can anyone tell me? Who is similar to Gracie? Among all these customers, who is similar to Gracie? No one?
Jack.
Okay. And who is similar to Rick?
Nick.
Denix.
Okay. So what we can see is we start getting a recommendation. So James and Rick has similar choice. So for example, James and Rick, they both like apple. They both don't want orange. They both like pineapple. They both like grapes. So Rick has bought milk, but James has not bought. So I can recommend milk to James. Likewise, Gracie and Tommy has similar choice. Mike and Danny. Now what happened is we have moved using the shopping pattern of each customers. I can build first level of recommendation. This can be built more deeper, but this is an outline of it. So problem number got solved. How to recommend similar product for them. Now second question is, when company like Amazon, every day they receive a pile of resume and they have a very small HR team. I cannot expand my HR team just like that. I need to think very intelligently. So this pile of resumes, I need to be very transparent. Without any partiality, I have to at least screen them. So what can be done? So what do is take the resume, which is in the form of CSV, scrape all the textual content from that. Like now the entire text of this resume, it doesn't need to have any meaning, but all the text comes in the form of a paragraph. Now remove all the stop words. Okay, stop words like the, is, and, etc. and all. And only focus on the words which are unique. Now we will be giving a scorecard. That is, if someone is having C++, give 5 marks. Someone is having Python, 5 marks. If someone is having programming general, 2 marks. Excel, 2 marks. Like that, we'll be giving a scorecard. Then start comparing and count every single, in this list, whatever is available, check whether that is there. If it is there, how many times it's there and how many times it's counted, and calculate a score for that totally. So now for one resume, I've calculated 23.5. The same program can be executed in a loop, and for all the users, all the resumes which are even a 1 billion resume, they may run it within 30 minutes or 40 minutes time, and it creates a new CSV file and give it to us like each username, their keywords and score. Now that's not enough. In the modern day, we need to think a little more deeper. There are a lot of data available in the market, so we can scrape the data from different angles, like bring from social media, like to see whether how is the personality, their interest. So Mike is basically a social bug. His interest is more on politics, sports. Jack is more of interested in arts. He's a very quiet person. Kevin is an extrovert, political and public. Now you can sort your column of your choice and pick the top 10 candidates, only screen them for an interview. So I am reducing my time going through each and every resume by using some levels of techniques. Problem number 2 solved. Now, which customer, see how many of them have seen that when you go and Google something on your mobile, you may get some result. When you go and do Google search on your friend's mobile, you will get a different result. How many of them have seen this? A context sensitive differentiation of things. When you go to Flipkart, all three of your friends just open flipkart.com and see all three will be seeing different products inside that. That is based out on your context. Now, the thing is, like, consider the company like Amazon, which is having a huge inventory of, there are millions of products inside that. And in a web page, I cannot bring all the millions of products in the front. So I should understand who are high paying customers, who are price conscious customers, who are quality conscious customers. And whenever they open the site, I want to only show them the product which they may be interested in. Else they may be sitting and they may get easily bored and getting diverted. Then they will never buy anything. So I have to use some techniques to understand that. How to do that? A very basic example. Whenever you use any e-commerce application, they start collecting information about you very deeply. That is, when each row is one particular user. For example, user number 1, whether his willingness to switch 1 out of 10, 1. He's giving importance for the price, yes, 9 by 10. That means how to know importance of price? That means whenever I'm sending any price conscious ad, whether he's clicking, how many times he's clicking? 9 out of 10. Importance of brand, he's bothered about brand? No, 2 out of 10. Frequency of shopping, 7 out of 10. Loyalty, when I'm any loyalty program, it's very 1. Usage levels, 10 out of 10 out of 20. Whether he's aware of ad? No, he's not aware of ad. He doesn't bother about it. So sales promo is whenever I'm sending any sales promo, whether he's responding out of 10, 5 out of 1, partially. So for every user, you start collecting information, and when you start applying an unsupervised learning technique like a K-means clustering, it start creating clusters and show us who is what. For example, this may be a low-paying customer, this may be a high-paying customer, this is a quality-conscious customer, price-conscious. So I can directly target them and show them things which are needed. Problem number 3 solved. Next, can I know what is our product's feedback all over? Whenever you see Apple iPhone or any movie which is coming, first and foremost thing after watching the movie, you will go to Facebook or Instagram or LinkedIn, anywhere. You start hashtagging that name of the movie and say this is crap, this is best, this is superb. All your feedbacks you start showing on the social media. So if I'm picking that hashtag and scrape all the tweets which are matching to that hashtag like this, I can get a list of different feedbacks. Now, if I do a simple sentiment analysis onto it, I can see who is positively speaking, who is negative, who is neutral. I can really see that. Now, when I apply it on a chloropleth map like that, I can clearly understand that, okay, there is a problem in CA and PA. Only these 2 locations, people are having a negative sentiments. I can directly call them and ask, hey, see, 90% of the entire US population, they are liking the product. Only these 2 people are having too high contrast. Is there any problem with your distribution or supply chain, or you have any issues in the stores? As a CEO, I can easily take a decision out of it. Now, let's see some data in action. After implementation of GST, rate of HIV/AIDS transmission reduced. Can anyone tell what may be the reason? After the implementation of GST, the rate of HIV/AIDS transmission, most of STDs have reduced. What can be the reason? And first and foremost, you should not think I'm pro Modi or against Modi. It's purely factual. Any guess or any idea? No one? No guess? Okay, I'll tell. How many of them have seen, see, when you generally take the transmission mode of HIV virus, you can see majority are from the sex workers, second highest are the truck drivers, third as the others. Now, how many of them have seen a scenario like this in the borders of 2 states? When you go from state to state, you can see in the borders initially it was like this. We call this an octroi tax. That means, for example, a truck which is starting from Kolkata, which is ending to Kanyakumari, it has to cross multiple checkpoints, and there will be sales tax, customs tax, like that. Multiple tax checkposts will be there. So sometimes a lorry may be idle for here for 1 or 2 days. Okay, and these are the kind of locations where the sex workers are highly active. Now, what happens is every truck, out of majority of truck drivers, they get infected in such kind of places, and they carry the infection throughout till their home. So recently, when they did a survey of taking 50 truck drivers and did a complete test on them, you won't believe, shockingly, around 30 to 40% of people were having STDs, that is sexually transmitted diseases. So how GST has helped us in reducing it? Very simple. After GST was introduced, there is only one tax. So most of the time, these lorries doesn't need to stay like that. They can come to a checkpoint. Within 10 to 15 minutes, they will keep on moving. So their wheels are always on the road. So that really reduces the transmission of STDs among all the truck drivers. So you can see a data is clearly telling a story if you really start asking from the right point of view. Now, can we see how India's weather pattern is since last 100 years? Okay, I'll show you. Can everyone see my screen?
Yes, sir.
Okay. So we took last 100 years of data across all the state, all the districts of India and see the temperature, and we started doing analysis onto it and come up with some interesting models here. So this model is, if I'm starting, you can see here, throughout last 100 years, how was India's weather pattern? You can see throughout the years, this region is always cold, and these regions are always cold. It's Western Ghats. Here also it's cold. And all other places are hot, cold, not extremely cold comparing to the Western Ghats and the top northern part of India. But one very interesting factor which I can see here is like throughout the year this is cold, so I can decide my final retirement spot here or here or here. But the most important thing you can see here is there is one area here and one area here which is having an opposite climate. That means when others are hot, they are cold. When they are cold, others are hot. This is running across the years. All the years, this pattern is continuously changing. So when we were thinking what may be the reason for this is, we end up in a conclusion. When I was traveling from Bangalore to Pune, when I landed in Pune airport, it was heavy rain. And I was traveling to a hill station called Lavasa, where there was no sign of rain. After that, next 2 days, I was returning. I saw huge rain in Lavasa, but when I'm reaching to Pune airport, no sign of rain. So basically, Lavasa is a valley. Valleys always have opposite climates. When others are cold, they are hot. When they are hot, others are cold. That's what's seen here. This is nothing but one is Bilaspur in Chhattisgarh, another one is Shimoga in Karnataka. Both are valleys. They tend to perform opposite climates. Okay, if climate is like that, how about the next thing? Can we see how shoppers move across shopping malls? We did an analysis onto it. That is, you can see how many of them generally go for shopping in shopping groceries in the nearby malls. How many of them? Okay, most people. You can see we did this analysis for a shopping complex in Singapore, and what we came to understand was very interesting here. That is, like, whenever you go to any shopping mall, we start connecting to the public Wi-Fi available today. So next time, and even if you go for a window shopping, your MAC ID get registered and start tracking your mobile connections. Using that data, we were trying to understand how is people movement across the shopping mall. So if someone who is coming from outside, you can see the thickness of line represents the volume of people moving from one to another. So majority of people go for fresh products first, second to the general merchandise, third highest is the apparels. This is a known factor. That is, whenever you go, your home is very much nearly located to any shopping mall. We go and collect most of the groceries from the shopping mall, and 90% of the time, all the groceries are in the front of shopping mall. This is a known phenomenon. So when someone who come from fresh product, you can see here is the space where a vegetarian and non-vegetarian gets, if they get separated. You can see the first highest place after fresh products is meats and poultry. That is nothing but the non-vegetarians. Even you're vegetarian or non-vegetarian, both of them need grocery, but only the non-vegetarian need meats, fish and poultry. You can see majority of people go. And what about the other vegetarians? You can see they mostly go for dairy, ready meals, and beauty and pharmacy, yogurts, dessert, like that, entertainment, general merchandise. Likewise, when people move from one to another, you can see the people movement across different shops. And after reaching to one particular shop, we are understanding something interesting, that the attritions are pretty high. That means people are finishing their shopping after reaching to this shop. So when we were investigating more into it, what may be the reason? we came to understand that BWS is nothing but beer and wine shop. How it we understood, the next nearest shop is nuts and snacks. So what happens is when people come for shopping, they keep buying the breweries in the last of the list. So once they come, they don't want to come directly and carry the bottle all across the shop. So they keep it in the last of the shopping list. Once they finish all the shopping, they come here, they decide to pick the bottles and they go. You can see here, data is telling a story here. This kind of models will help you to like rearrange the shops to get equal amount of people movement across. Now, how many of them have watched Game of Thrones? How many of them have watched Game of Thrones? How many are a big fan of Game of Thrones? Okay, you can see a lot of people have watched Game of Thrones, especially when during the pandemic, the most interesting thing which people were doing were like watching different series. Among them, Game of Thrones was one some interesting. So we try to do some analysis on how people are like, how Game of Thrones or the entire series, without seeing the series, can I make some story out of it? So that led us to build a data set about Game of Thrones. From the complete, we did complete scraping on the text content and start building a network like this to see who are the most influential characters in Game of Thrones series. So what ended up here is like all the bubbles here are nothing but one character in Game of Thrones. If you're aware, if I'm hovering onto it, you can see the big circle. Jon is one of the most important character. Tyrion is one. Jaime is one. Cersei is one. Arya, Howard, Ned, Sansa, Theon. All these names, are you aware of it? How many of them are aware of these names? Okay. Now, if I just go and click anyone like Tyrion, if I click Tyrion, who are the others he's connected to? All these small dots are also different small character, but their roles are not greater. The bigger the circle, they're more referred in this series. So this is interesting. Now, what I can see is I don't want to have the small characters. So what I will do is I will use the degree of centrality and I will just move it and I will reduce the peoples who are not important in this. I'm going to set up a threshold and moving people who are not that much great important. And I end up in a network where I have some interesting people. So who is this person who is connected? Jon. If I'm pulling Jon, you can see who are the others he's more influenced on. And if I'm pulling here, you can see here, there is one character called Cersei who is directly connected with this one person. That is like Joffrey, and under Joffrey, these are the people who are connected under him. So this kinds of network diagram will really help us to explore most influential areas in the area of fraud detection, in the area of COVID contact tracing. We can understand the network, how they are influenced and how they get propagated. So what we are seeing all these times is very interesting aspect. So next thing I want to take is, give me a second. Yeah. We have seen Game of Thrones. We did one level of analysis to see like how is what people say about different states. So when you go to Google and search this phrase, why is dash can be anything, any state name or a district name like that. If you go and type why is, put any state name. So you can see top 10 recommendation. Out of that, the first recommendation one is the very commonly searched keyword. So when we did it all across the districts, you can see this is the kind of map which we started seeing. That is, why is Kerala so, God's own country? Why is Tamil Nadu so against Hindi? Why is Andhra Pradesh splitting? Why is Telangana created? Why is Maharashtra richest state? Why is Madhya Pradesh poor? Why is Rajasthan dry state? What you can see here is, this is what is a real trend which is happening in Google. When you go and search what people commonly search, and the highest search common keywords are this. These are the things which they search for. So we start getting data from different sources and we start using it in the right way that makes more important sense. We did another analysis for a restaurant network like Starbucks, and there are 4 different units of Starbucks: Unit 1, Unit 2, Unit 3, Unit 4. And this is across the years, how's their sales. Unit 1 and Unit 2, they are very poor during the first December, January, February. You can see the sales are very less, sales are very less. Unit 4, always the sales are very less. Unit 3 tend to perform better comparing to all other units. But especially on all Wednesdays, you can see a dark orange stripes only on every Wednesdays. And you can see only on Wednesdays, Unit 3 is having slightly better performance comparing to all other days. What we have found in this, on every Wednesdays, the person who sits in this counter takes a half day and goes. So what happens is people who come to this counter goes to the nearest counter, that is Unit 3, Unit 4. That's the reason all the people who used to come here start redirecting to here. That's why this unit start showing slightly better only on Wednesdays. Then why Unit 4 is always underperformant and Unit 3 is always an overperformant? The reason is both of these units are in the nearby location. So what happens is there are not enough population there, but there is 2 units there. That's the reason the Unit 3 itself is able to satisfy majority of the population. That's why their sales are pretty high. So very less number of people comes here. So once they move this Unit 4 to a different location, the Unit 4 also tend to perform exactly similar like that. So you can see data helps us to take decisions. It really drives us in the right way. Okay. If all these things are there, let's see how US births are. How birthdays? Is there any pattern we can identify births? Yes. You can see here, this is a birth calendar of US for 1 year. Okay. The darker the cell represents, number of births are higher. You can see 13th of every month, the number of births are very less. It's a superstition. People doesn't want their kids to be born on 13th of 13th is considered to be a very not an auspicious day. They don't want their kids to be born. New Year holidays, no births, and more number of births during February 14th, that is Valentine's Day. People feel it's a very auspicious days to have more birth. And St. Patrick's Day, number of births are very high. No one wants their kids to be born on April Fool's Day. During Independence holidays, no births. There are Thanksgiving holidays, no births. There are Christmas holidays, number of births are less. Now it's more looking like a holiday calendar than a birth calendar. Okay. If US is this much superstitious, how is India? This is a calendar map of Indians. You can see there are dark stripe. After July, births have totally declined. August, September, October, November, December, births are very much declined. And especially on 5th, 10th, 15th, 20, 25, you can see dark circle. You can see more number of births in India are happening only on 5th, 10th, 15th, 20, 25. So when we really look into this data, we can understand that all these dark representations are fake. That means people fake the birthdays. They flunk the birthdays. So whenever they put a birthday, they put a round number. So it is pretty much easy to remember. And does this really affect their marks? The same students' 10th standard mark has been taken here. You can see people who are born during the 5th, 10th, 15, 20, 25 tend to perform very poor than the one of the other. And people who are born after July, that is August, September, October, November, December, tend to perform very well than the one who was born during Jan to July. What is the reason? What is the phenomena behind this? The reason is very clear that when these fake numbers are nothing but they are admitting their newborn kid as soon as possible into the pre-KG, where they already put it with a group of people whose brain developments have been done, but they are of little higher age. So that really continuously repeats till their 10th standard. Now, with all these things, what we can see is nowadays Google ability to catch spams 99.9%. You can see majority of spams go and landed in spam folder. Now Google is making very good decisions through that. Next thing is these days, if you go and chat on any chatbot, you will never understand whether you're chatting with a chatbot or a real person. That much context sensitive the AI systems have become. Identifying disease. First time in the history, generally to find a vaccine, it will take minimum 5 years and more than $5 to $10 billion investment. First time in history, for a pandemic, we were able to come up with a medicine within 8 months' time. This is because of heavy number crunching machines available and very good AI systems and models trained. You can see ability to identify disease has gone very much higher. If you open Uber, put a location, its ability to identify your shortest route, optimize the route, are mainly because of most of the AI technologies which is available. Now, what I really want to tell here is data science business outcome is more important than ML, DL and NLP topics. So be a more of a data centric person and start working towards that. So with that, I would like to wind my talk and open for your questions. And I'll share my LinkedIn profile. If anyone want to connect with me, feel free to connect here. Let me share it on the chat box. And I'm open for the questions. Hello? Am I audible?
Yes, sir.
So feel free to post your questions. I'll be happy to answer you.
Sir, I have a question.
Yes, please.
Okay, so sir, if I want to start data-driven decision science, so what will be the roadmap or what will be the flow I have to follow?
First thing is, from the day one, whenever you get a data, take any set of data very interestingly and start exploring it using basic statistical techniques. Like be strong with some of the descriptive statistics, inferential statistics, understand how to analyze data and focus more on data analytics rather than going and building machine learning models. Then it's a practice. Regular practice is the most important thing which makes a great data scientist, and that's what I always suggest. Hope I answer your question.
Yes, sir.
Okay. How do you select the correct data? Like you select a number of kids in it. See, that's what the domain knowledge will help you to create new features. For that, there is a separate area where you need, that's what you should understand the domain better, then the data, then start creating the right data questions and start exploring it. That will give you guidelines on how to create new features from when you don't have any features.
So basically, when you gave the example of the Titanic one, so you selected the data and distributed the data on the basis of the crisis or the information we were provided, right? So how to know that what criteria is important or what the problem is all basically about and distribute the data accordingly?
See, first and foremost thing is if I want to predict a person will pass or fail, and I'm having a lot of data about a person, and there is a field like which color dress he is wearing, those things are not relevant for that answer, correct? But same time, how much time he's spending will be a right feature, correct? So we should be able to understand for the answer what we are trying to predict, are we taking away the unnecessary data points and keeping only the one which is relevant. These things will come when you know how the decisions are taken in that field and on what basis the decisions are taken. So I would suggest understand that context very clearly and eliminate the data points which are not relevant. First step, these two things should be done. Third thing is audit the quality of data set and understand whether the distributions are trying to be maximum nominal or normal. Then start analyzing it. That will really lead you to get right kind of insight to make any good models.
Okay, sir.
Hope it's clear.
Yes.
Okay. Yeah. And if anyone is interested to know more about data-driven decision making, feel free to connect through LinkedIn, and I will add you to a data storyteller group which I'm maintaining. And there are a lot of good things which happens there. We keep them posted. And if there is any good option where we can collaborate and work, I'll be happy to invite you people to that. So I think everyone are done with the questions. Any more questions? I got one question from Zakira Singh. So I'm interested in data science used in astronomy, like detecting planets and black holes using images. What skill do? It's generally when you work on astronomical data, it's more on it's more of computer vision challenge on image recognition or object recognition, especially that really focus on CV, that's computer vision. So I would suggest you to go and understand a little deeper about computer vision. That's where you can really get more idea on.
So I have a question.
Mm-hmm.
Sir, analyzing a data and interpreting a data, are these two different things?
Okay, let me tell you, like you have a data, like you have a data set of, keep it like breast cancer. And if you start going building a model, your model will give you 90% accuracy or 99% accuracy. But what will happen is when you really apply the model in real world, your model will be zero. That means it won't be able to correctly predict anything. But same time, there will be some models which may be predicting only 60% accuracy, but it will be far better than the one which is predicting 90%. Now, that point the question comes, how that is possible? 90% I'm getting accuracy, but it's not performing well. But the one which is giving 60% accuracy is able to perform well in real world. That point, you need to interpret the data and understand, okay, if my data points are like this, my distributions are like that, model A will work well. If my distributions are like slightly different or it's totally different from what I'm seeing, I think model B will be working. So data analysis is about interpreting the data and creating actionable insights. Hope you got the idea.
Yes, sir. Thank you.
And this machine learning model and all these things when you build, you should have very strong data analytic knowledge in order to convey how your model is working. Else, your model will be always a black box model and company or no one will be dare enough to take it to production. It will be a shelf product only.
Yes, sir.
Right?
The
voice is very feeble. Hello?
Hello, is it audible?
Hi, Gunjan.
Hi, sir.
Happy to see you, yeah?
Yeah, me too. Same here, sir.
Okay.
Sir, it's not a new question, but for the clarity purpose, for my clarity purpose, I just take the opportunity. When we say the interpretation, because how we are doing the analysis is up to us.
Correct.
But until we are not able to convey the interpretation, then everything will not be of productive. Like you said, the whole model will be a black box. And there's no hard and fast because it comes with the experience. But can you share with your experience that what are the best practice or the thumb rule for interpreting data? Like how, because it is quite difficult to put it in words, but that's why I'm throwing that question to you.
Got it.
To make it little simplified.
See, I would say, for example, like that's what I say, right? Like rather than becoming more of a model-driven person, first start with basic analysis on the data and make sure that for example, if I am taking a data set and which is having a very uneven distribution of data points, ultimately my predictions also will be like that. Now, if I'm having one class very much higher, I mean like 70% of percentage of data is about male and 20%, so 30% of data is about female, still it's unbalanced. In that kind of situation, I should always have a consideration that if my model is predicting more favor for men, that means my model is strongly understanding there is 70% bias in that. So it's about going column by column and seeing the distribution and understanding, okay, if my distribution, I have limited data, but my distributions are very much favoring to one particular class. So I cannot blindly believe this model when I'm taking a decision whether this is belonging to a male or female. But I can believe in the terms of their cholesterol level or diabetes, all these levels, I can even believe because that's not, whether irrespective of male and female, that will be different. So I would say from the best practice point of view, start knowing your data very strongly, spend 70% of time on analyzing point by point, see different how is the distributions of data, then start asking the questions and form your intuition, then start scoring which of your intuition it's more favoring for that data. Got my point, Gunjan?
Got your point, sir. But the question is like, I have done all my analysis, everything is done, and I have the best 2 or 3 model options available. But the question is that how to transform my convey my interpretation in a best way that that directly goes to the mind of the other side of the person. And is it so? Just
have you done your analysis first?
Yes. So the background is I've done the analysis with all the data. I have got all the facts. Now it is about conveying to the other side of the person and conveying in such a way
the business. You have to convert that general model metric centric into model of business centric outcomes.
Yes.
So fine, like we can spend that more time detail. You can directly reach me because that's called model interpretation. I will help you in that. Or else next session itself we'll set up in that, especially focused on model interpretability. It's little detailed, so I will bring up with the correct PPTs, whatever you want, with the right example. So it will help you, and that is a very important thing which we will keep it as an important topic to discuss. Fine.
Sure, sir.
We'll do it.
I'll be waiting for that. Thank you, sir.
Problems. Yeah. His career building and data-driven decision-making bifurcated further for different... See, I would say data-driven decision-making. Initially, data analytics was a skill set which is good to have. But now I can say data analytics is a skill set must have in every domain. Because you don't focus on becoming a specialized person in that, but become a person who adds as a skill set which will definitely make a lot more changes in your actual life. So irrespective of any domain, how computers have penetrated into, right now data analytical skills should be a part of every single branch which will add value add for you. Okay. I hope we are running out of time. Anushka?
Yes, sir.
Shall we wind up?
Yes, sir. So shall we move forward to vote of thanks if there are more questions?
Yes. Feel free to, if any questions are there, feel free to reach me or through my LinkedIn, which I've already shared it in the chat box. And yeah, please go ahead, Anushka.
Yes, sir. Thank you. So thank you so much, sir. Indeed, we learned a lot, and thank you for your time and effort which you took to share your knowledge and experience with us. Also, I would like to thank Medicaps University and all the authorities for their help and support. And last but not the least, I would like to thank Dr. Nitika Vatsuhan ma'am and Mrs. Neha Sekha ma'am for their constant support and guidance in making such events possible and successful. So we'll be floating a Google form, that is attendance form, in the chat box. So all the attendees here, please don't forget to fill up the attendance form. Okay. So thank you and have a wonderful day. Thank you, sir.
Thank you, Anushka, for that brief support throughout the thing. And I would always say, like, focus on more on techniques rather than tools, irrespective of whatever domain you're working, and be very crystal clear in what you're trying to solve rather than going into different verticals and trying to conquer. Be a person of one domain specialist rather than multi-domain. Thanks.
Yes, sir. Sure.
Okay then. Thank you.
Thank you, sir.
All the best.
Thank you, sir.